Okay, let's see.
Oh look, we're live.
Haha, enjoy, Mr.
Okay,
Lab.
so my name is Grant Smith, and this is my presentation on blood pressure. I'm not sure if this will be following all the rules, because I'm not really sure what classifies as a presentation. I have most of my notes on paper, and then I have 9 slides, including the quiz and the answer key for the quiz. This presentation was made for Ohio Connections Academy and prepared for my anatomy and physiology class taught by Miss Dunlap. Okay, so start with, what is blood pressure? Blood pressure is the pressure the blood exerts against the inner walls of the blood vessels and the force that keeps blood circulating continuously even between heartbeats. So, what this means is that when the heart pumps out blood, it's trying to send it all the way throughout the body. The amount of pressure that the heart can push the blood with is what we would call our blood pressure. So, in the description, it mentioned the pressure in the blood vessel. So what is a blood vessel? Blood vessels are basically just tiny tubes that send and circulate our blood through our body. And blood vessels can be broken down into 3 different categories, which are arteries, capillaries, and veins. Blood vessels are part of the circulatory system, and actually it's called microcirculation. Okay, they are designed to transport our nutrients and oxygen to the tissues of the body. Blood vessels can also carry away waste and carbon dioxide from the tissues back to the heart. And all blood tissues will rely on our blood vessels. So to start with, we're going to start with arteries. What are arteries? Okay, so arteries means it's carrying blood away from the heart to capillaries. In our body, we have over 20 major arteries that branch into complex network of even smaller arteries. Each artery has 3 layers. They have a smooth layer on the inside, a thick layer of muscle in the middle, and a rough layer on the outside. Arteries carry oxygenated blood away from the heart to the tissues. There are only 2 exceptions of arteries that do not carry oxygenated blood, which are the pulmonary and the umbilical arteries. These 2 arteries are going to be carrying deoxygenated blood to organs that will oxygenate it. Now, there is one main artery that is kind of the biggest one in our bodies, which is called the aorta. That's spelled A-O-R-T-A. The aorta is our main artery. It is the root systematic artery. It is the base for all branches that will be going out and sending blood to the capillaries. And it receives blood directly from the left ventricle of the heart via the aortic valve. Real quick, I'm just going to list off a whole bunch of the major arteries. I'm not sure if they have all the really tiny ones labeled, but like I said, there's over 20 major ones, so I'm going to list the major ones. There's the subclavian artery, the aorta, the axillary artery, the descending aorta, the brachial artery, the radial artery, the the ulnar artery, the digital artery, the arcuate artery, the dorsal digital arteries, the basilar artery, the internal carotid artery, the external carotid artery, the vertebral arteries, and the common carotid arteries, the pulmonary arteries, the celiac trunk, the renal artery, the gonadal artery, common iliac artery, internal iliac artery, external iliac artery, femoral artery, popliteal artery, anterior tibial artery, posterior tibial artery, and peritoneal artery. Okay, moving on to capillaries. Okay, so capillaries are any of the fine branching blood vessels that form a network between the arterioles and the venule, which I think are very scientific words for our arteries and our veins. They are the in-between point for both of those. The size of a capillary is 5 to 10 micro in diameter, which is known as the smallest blood vessel in our bodies. The function of the arteries is they are going to convey or transfer the blood between the arterioles and the venules. They bring the nutrition blood in to give the nutrients to the tissue, and they take away or pick up waste to carry away. So if we imagine back to, in your head, picture this, right? So your heart is going to be pumping out blood. Okay, it's going to send it into your arteries. Your arteries are slowly going to branch out towards all of the different capillaries to try and reach as many of the tissues in the body, because it actually reaches all the tissues in the body, right? And so it's going to send it to the capillaries. What the capillaries basically do is they allow the blood to kind of almost squeeze out the nutrients, and they can flow into the tissue, and then they can even have some waste and other things come back into the blood. So it's not like it's giving and taking blood, it's almost like it's filtering out and then filtering back into the blood. One moment. Okay, so individual capillaries are part of the capillary bed, which is an interweaving network of capillaries that will be supplying tissues and organs. Because like we said, blood vessels are going to send blood to all tissues all over the whole body. So the more metabolically active a tissue is, the more capillaries are required to supply nutrients and carry away waste products. Okay, so a little deeper into how the capillaries work is, like I said, the blood flows from the heart through the arteries, which branch and narrow into arterioles, and then branch further into capillaries, where the nutrients and waste are exchanged. The capillaries will then join and widen to become venules, which in turn widen and converge to become veins. And then the blood will return back to the heart through the venae cavae to then go back to the aorta and get sent back out. There are two types of capillaries. True capillaries, which branch from arterioles and provide exchange between tissue and the capillary blood. And metarterioles, found only in the menstrual circulation. They are short vessels that directly connect the arterioles and venules at opposite ends of the beds. Metarterioles are found primarily in the mesenteric microcirculation. The physiological mechanisms underlying precapillary resistance is no longer considered to be a result of precapillary sphincters outside of the mesenteric organ. That was completely useless information. My bad. So, once again, it's just big artery shrinking into a capillary, and then slowly growing back into a vein. Three types of blood capillaries: continuous, fenestrated, and sinusoid. Continuous capillaries have an opening or pores, so the lining is continuous and only allows small things like water to get through. So it would be like taking a PVC pipe just cutting little slits as thick as a knife. So you saw a slit, but real small ones, because you don't want very much to be able to get out. But the fenestrated capillaries are capillaries with small pores throughout the lining, allowing some more things to transition. So maybe you just have even more, just put some more down. Now, the sinusoid capillaries are almost an open pored capillary with lots of holes in them to move nutrients and waste in and out. Okay, now, moving on to veins. Veins are blood vessels that carry blood towards the heart. Most veins carry deoxygenated blood, whereas the arteries carry oxygenated blood. The two exceptions for the veins, just like the arteries, are the pulmonary and the umbilical veins, which carry oxygenated blood to the heart. Veins are less muscular than the arteries and closer to our skin, whereas arteries are deeper inside. The structure of a vein and different types of veins are the superficial, which are the closest to the surface, and they don't connect to arteries. And there's deep, which are deeper into the body, and they do connect to arteries. There's the perforator, which drain from superficial to deep, usually referring to our lower limbs and feet. So that would just be like the ones that we can kind of see, which means the superficial, so the ones that are closer to the skin, and then going to the deep, so they're that transition vein. There's the communicating, which directly connect to superficial to the deep. So it's not as much of a drainage as it is really just a connection point. And then the pulmonary deliver oxygenated blood from heart to lungs, like we said, and the systemic drain to the tissue to body, deliver deoxygenated blood to heart. Oh, okay, sorry. They drain the tissue and then they deliver the blood to the heart. So those are basically the ones that go straight from the tissue to the heart. So, like I said, you start with your arteries coming out. Arteries are bigger than veins, and they're more muscular than veins, like we said. So the heart's pumping, it's shooting blood out, and that's how the blood kind of moves through the whole body, is the continuous pump that the heart is going to be giving out. Okay, so it shoots it out, it's trying to send it to all the tissues because the heart just gave it lots of nutrients, and it's got oxygen now,